This video will cover the functions necessary to complete the first assignment. And I really think that it also can serve as a template for your homework assignment as well. So I highly recommend you follow these steps. And within these steps, actually, there are a couple answers to the assignment. So it should also kind of help you get your feet kind of under you in order to understand both the data and the necessary functions to start answering some of these questions. Apologies that this is coming out a little bit later than I'd hoped, but I appreciate your understanding. So first we're going to upload some packages. You'll notice that there's a lot more than when we were doing assignments in policy 610 that some of you might have taken. This time around, we're going to be using a lot of different packages. So these are the ones that we're going to be using. Um, I kind of list right here what these packages do. Um, and so what you're going to have to do is, if you're on RStudio Cloud, to install all these. Now, some students have asked me if you need to do this every time. For those who are not using RStudio Cloud, for who have it on your computer, in general, you just have to do this one time. And whenever you open up a new workspace, you can just simply type in the name of the library here. But for those who are using an RStudio workspace on the cloud, you're going to need to install these. I've already done that, so I'm going to go ahead and run that. And as usual, I'm going to run it a couple times. And if it's just blue, then that means that it worked. So we're in business. And so what we're first going to do is, as I showed in the last video, we're going to save these strings, which are just files on the website that we can grab the data from for this assignment. And so this is the actual name of that link, that hyperlink. This is what I'm going to be naming the zip file, and then I'm going to use the download file function, and then I'm going to unzip the file. So we'll just do it step by step. I've already saved those strings. Then I'm going to download the data. So you see I have a zip file there, and then I'm going to unzip it. And now we have this new folder. So I'm going to do this a couple more times. I'm also going to download the weights. So it's at this URL, and I'm going to name it something different this time. So I'm going to name it underscore weights. So I save that string. And then again, I'm going to use the download file from this. And I'm going to do that. And now you'll see I have another zip file in there. And then I will once again unzip. And then again, we have a new file. And then we're going to start importing the data. So this was the downloading of the data. Now I want to import the data. So the first file that I want to use is this file. So it's contained within this folder. It's going to be the c_cv.dta. I'm going to save that file name, and then I'm going to put that file name inside. If you wanted, you could have just done this right in there, but I didn't. So I split it up, and I'm naming this data frame df house. And now you'll see that I have a data frame up here. So now that that data set is imported, we want to also import the weights data set. So I'm just going to import this, and I'm going to name it df weight. And you can see that there's just the folio column and then this. And the right side column is the weights. So what I want to actually do is rename that column to weights. If I use the rename function here, I can give on the right side the existing name, and on the left side it will be turned into the name I want it to be. And so if I ran that, it would kind of print out the whole thing because I didn't save it, but now it will be renamed weights. So I want to just overwrite that file by typing in the name of the file and running this all over again. And we can check whether that worked by using the names function, which shows us our column names. And so now the column names are folio and weights, which is good. And then I also want to do one more manipulation that's a little bit complicated, but it has to be done. So you're going to use the mutate function, and you're going to be overwriting the folio column. So if you see here, the folio column has all these leading zeros, and we just need to kind of get rid of those in order for this merge to work. and I'll show you that in a second. So what we're basically going to be doing is taking out the leading zeros. What does that mean? Well, I'll try to show you first before I save it. So you'll see here now that if I name it folio new, then you can see there's going to be a new column called folio new, and it's basically just that folio column, but without the leading zeros. So now if I name this folio, it will overwrite this. So you can see now it's been overwritten. And I want to save that, and I can do that, of course, by typing in the name of that original dataset and setting it equal to that manipulation. And so now that should have worked. We can confirm that by just looking at the first couple rows. And it looks like it worked. Okay, so we just have one more data set to import. And it's again from this folder, so I need to specify the name of that folder and then the name of the file. So if you click in here, you'll notice that this file's in there. Okay, so now we have our 3 data sets. And now I want to merge some of our data. So first I want to make sure that there's overlapping column names. So the DF weight dataset has folio and weights columns, as we showed earlier. And the house dataset has a whole lot of columns, but you'll notice that there is at least this overlapping data. So the folio and folio just represent the household, basically a household identification number. And because they overlap, we can merge a lot easier. So So what we're going to do in this one is use the merge function, and in it we're going to put the df weight and the df house, and then we're going to merge it by the folio. So the spacing doesn't matter, but just kind of clean that up, and you'll see that it looks like it successfully merged. So what we're going to do is give it a name. We're going to call it df. We're going to run it, and actually I keep highlighting this and highlighting all the code. You don't actually need to do that. All you need to do is set the kind of cursor after the last piece of code and type in command return if you're on a Mac, and it will run that whole line. And you can see it did. It ran it and it was successful. So now we have a new data set called DF, which is a merged data set of DF weight and DF house. So now we can finally get on to the business of solving some of our problems. So we need to first, we're going to try to answer the total household size, the average household size, and the standard deviation. And so in order to get there, what I want to do is I want to count the number of folios. And essentially what that will do is this data set is the df-ind data set. So it's this longer one here that I imported. It's not the merged one. Essentially, this is a data set with a whole lot of folios or households and many different LS numbers. And the LS numbers are the individual IDs. So you can see how this household here has 1 person, 2 person, 3 person, 4 persons, 5 person. And that's just counting each person within the family. And so what I'm going to do is I'm going to use the group by function. I'm grouping it by that folio because folio is, it has overlapping values. So that's what I'm grouping by. So it's essentially counting all of the unique folio values and counting how many times they show up. So let me just show you what I mean by that. So I think I already ran that code, so you can see it below, but I'll run it again. And so it says that folio 1000 has 4, folio 2000 has 5. So let's check if that reflects the reality. So that's right, folio 1000 is 4 and folio 2000 has 5. So it's just essentially counting each of these, which represents the number of people in the house. So that's how I did that. And I'm actually saving that as a DF called DF home size. So you'll see that that data set is actually in there now, DF home size. And then I can kind of check out whether that worked by looking at it there, and it looks like it did. And I want to rename this N. I want to rename it family members. So I'm going to run this code, and you'll see that now it says family members instead of N. And now the last step I want to do is to merge in that df weight that we had before, and I'm going to merge it by that folio again. And so I'm just going to run it. And it looks like it worked. And now we have folio, family members, and weights, right? So we just tacked on another column there by merging it. And now we can actually take the mean and find out what the average number of family members there is. So I'm going to use the summarize function. And so this is these right here could be anything you wanted. It could just be mean and SD. And then I'm setting it equal to whatever manipulation or function I want to use. So in this case, I'm going to use the mean on the family members column, right? That's what I want to take here. And if I run this, it looks like it worked. So that answers part 2 or question 2. I want to show you how to do the regular mean first before I show you how to do the weighted mean. So that's why I say unweighted here. And then I just want you to realize that there are also other ways you can go about doing this. So you can use the summary function, although the summary doesn't give you the standard deviation. You could just select one of the columns individually and use the mean function or the standard deviation function. But I really want you to be able to use this one if possible. No worries if you get the answer a different way, but I just wanted to show you alternative methods. So now that we have the mean for the number of family members, we can go on and answer. With weights. So we do that by using the as survey function. And inside of that function, we want to put in weights equals to weights. The weights this here is just the weight column name. So if it was N, if we had just kept it as N, or actually not N, if we had kept that column name as FACLIBC, if we had not renamed it, then we would put that in there. But because we renamed it, we put in weights. And then after that, we put the pipe operator. Remember, pipe operator Command Shift M on Mac is the shortcut. And then we put the summarize function. And then we set that equal to almost similar to what we did before. Again, these are whatever we want to name it. So let's say mean and SD for now. And instead of using the mean function, we're using the survey mean function and the survey standard deviation function. And we're going to run it. And now we have a slightly different standard deviation and mean. Let's just run that again. Compare it, and you'll notice that the mean is now slightly different because we've added the weights. So you can also use the weighted mean function if you wanted to, and inside of it put family members and weights, but there's unfortunately no weighted standard deviation. But I just wanted to show you that, again, there's another way to go about this if you wanted, right? And you can see that actually these are equivalent. So let's just run both the methods. You'll see that's equivalent. And so this function actually, and this function as well, so as survey and survey mean come from the survey or SRVYR library. I just wanted to show you that. And so after that is complete, we can move on to the second part of question 1. So now we want to answer the number of children under 18 in the household. We're going to first create a new data frame for children under 18. So I am going to use, again, that df_ind data frame, and I'm going to filter out the LSO2_2, which is age. And you can get this information from the code book, which I'll provide a link for. And so you can understand that this represents the age column from the code book. And then I want to group by folio, and I'm going to count again. So I'm going to count how many people are under 19 in each house. So it's kind of the same strategy as I used before, except this time I'm using the filter function to filter out anybody not over anybody over the age of 18. And so I'm going to save that as a new data frame. And so now you'll see it says DF under 18. That's my new data frame. And once again, I want to merge in the weights. So let me show you what the DF under 18 looks like first. DF under 18. Just show the first couple rows. You'll see it's just folio and the number. And then I want to merge this in. Now I should have the weights. As you can see, now I have the weights. And I'm going to rename it. Rename that N column. So now it's number under 18. So number of people under 18. And I just want to take the, oh, this is the weighted mean. So the unweighted mean is just this same thing here, but instead of as survey, we're just going to use means. You can run it, and then you'll have the unweighted mean. I'm just taking the mean of the number under 18 column, so that's right here. And then for the unweighted, we are going to take the as survey again, weights equals widths, summarize function. Inside the summarize function, again, name this whatever we want, mean or SD, and inside we're going to put the survey mean, survey SD, and then select that column that we want the mean from, run it, and now you'll notice again, mean slightly different. Standard deviation, not so much, but the mean slightly different. All right, so that's how to answer the second part of question 1 and 2. Now we're going to do a slightly different question, and we're going to be using a different data set. So we're going to be using that DF data set that we created earlier. We are going to show CV16, which is related to a question of whether a household has a toilet, and it will be 1 represents that they do. So again, this information is in the code book. And so there's a number of strategies we could go about doing this, and the same goes for above. If you did it differently, more power to you, that's great, as long as you arrive at the answer, but this is just the way I'm doing it. So what I'm doing is creating a new column. It's going to be called dummy toilet. And that dummy toilet, what I'm going to do, I want to break this into a couple pieces here for in order to show you what's going on. Oops. Oh, did not want to do that. So what I'm going to do is create this dummy toilet, and then I'm going to select the dummy toilet and that column that I created it from, so CV16, and you'll notice that it's equal to true if it's a 1. I'm trying to find a way to show you observations that are not 1. Yeah, so if it's equal to 3, it will be false. If it's equal to 4, it'll be false. So why am I doing this? Well, because a dummy is when you have a 1 or a 0. So I can get a 1 or a 0 by saying as numeric. So as numeric, and then putting that around there. I'm going to do this once again. Run it, and you'll notice that the 1s are 1 and any other number other than 1. So 2s, the 3s, they're all 0s. So basically, what does this tell us? This column tells us whether a household simply has a toilet or not any other conditions, which is what the original question asked. So now I want to go back, and I'm going to erase all this, and I'm going to just say df equals to df, and then this manipulation. And now we're going to have that extra column in there, and we can compare the new column to the old column. Now we should be able to answer the percentage of households that have a toilet. So well, before we do that, we'll notice that we have a couple of NAs. And so I want you to be able to remove those NAs. We do that with the filter function, not equal to NA, so that will remove it. And you'll notice that there's no NA. So this time we'll use that same filter function and then the summarize function. And you can name this whatever, mean, and then that gives us the answer. Now you should be able to add the standard deviation here. And now we are going to do that same process, but we are going to use, again, the filter function and then the add survey as we've been doing to get the weighted means, and then summarize, and then survey mean, and then inside of it, that dummy toilet. Okay, so that will give you the answers to the first couple of questions in problems 1 and 2. Um, Again, the weighted one I think is actually question 1, and the unweighted is question 2. But you can present your findings like that, um, side by side. And I just want to take like 1 second to understand why dummies equals kind of a mean. Because if you can think about it, like a dummy is a 1 or a 0. So an observation of 1 will be counted towards the mean, obviously, as 1. And an observation of 0 obviously will add nothing to the mean, but it will be part of the denominator. So if you had, imagine you had a dummy column that had a 1, a 0, a 1, and a 0. You would have, if you wanted to take the mean of that, the numerator would be a 2, and the denominator would be just the number of total observations, so it'd be 4. So in this case, if we took the mean of this list, we would get 50%, which would be the exact mean, right? So that's just kind of a quick explanation of why dummies equal a mean. I did not answer the rest of question 1 for you. You're going to have to do that yourself. I did give some hints about where you can find those data sets. You can either create a dummy, as I did before, create a new column, or you can recode, which I showed you how to do last week, in order to get these answers. So please put your manipulations here and your unweighted and unweighted means here. And obviously you should follow what I was doing up here with weighted mean using as survey and survey mean. Okay, so you're gonna have to answer these questions. Proportion of households with a separate room for cooking, proportion of households with a telephone. You're gonna have to do those. Proportion of households with a dirt floor. And for this question, you're actually going to have to use another data set, which I show you how to import that here, but I'm going to make you merge it yourself. And you're going to have to do the unweighted and weighted means. Now for question 2, I'll give you more hints, but I'm not going to give you the answer. You have to filter for the head of the household. So LS05_1 is equal to 1 is filtering only the head of the household. So the head of a household equals to 1. Other household members are given a different number. So like if it's a son or a daughter of the head of the household, it'll be, for example, like a 2 or a 3. I don't know off the top of my head. I'm just giving you an example. And then what you're going to need to do is, after you've filtered it, um, you are going to try to understand the proportion who have completed primary school. And so that is actually in LS14. And I kind of gave you one potential solution here, but I want you to try to take a crack at it in other ways too. And I'm not going to exactly show you or explain to you what this means. You're going to have to try to understand what I'm doing here based on what I showed you before. But this is kind of a start for you. And then I'm going to make you look for the whether they're working or not by looking in the code book and trying to manipulate that data yourself. And then for the final question, characteristics of households between the age of 6 and 18, you're going to have to do this for yourself. This age column here is not is actually not titled age column. You're gonna have to find this for yourself. And lastly, when you after you've made these manipulations, you're gonna have to plot it. And I suggest you use ggplot, and I showed you how to do this last week in last week's lecture, so you can get it from there. So this was hopefully gives you a way better idea of how to go about answering the problem set, and it also provides you the necessary files and data you're going to need. So just make sure that you reach out to me if you have any questions. And yeah, thank you for understanding with with the late nature of this video.